Why does it take this long? Remember, the signal has to go out, bounce off the target, and come back. Obviously, radar is not a feasible method for determining how far away these stars are. Other methods include standard candle measurements using variable stars and supernova. A standard candle is an object of known constant brightness. By measuring how quickly the light from a supernova explosion decays, for example, we can determine its intrinsic brightness. Because such standard candles are objects of known brightness, by measuring how bright they appear from Earth, we can determine their distances. This technique depends critically on the assumption that all supernovae behave identically. Of course, this is not completely true. Because of this, the derived distances will have some errors. In contrast, the parallax method is a direct, cleaner measure of distance. Parallax is the angle by which something appears to move across the sky when an observer looking at that object changes position. By observing the size of this angle and knowing how far the observer has moved, one can determine the distance to the object. Today, you will experiment with parallax and develop an appreciation for the small angles that astronomers must measure to determine the distances to stars. To get the basic idea, perform the following simple experiment. Hold your thumb out in front of you at arm's length and look at it with your left eye closed and your right eye open. Now close your right eye and open your left one. See how your thumb appeared to move to the right? Keep staring at your thumb and change eyes several times. You should see your thumb appear to move back and forth relative to the background. Of course, your thumb is not moving. Your vantage point is moving, and so your thumb appears to move. That's the parallax effect. How does this work for stars? Instead of switching from eye to eye, we shift the position of our entire planet. We observe a star once, and then wait 6 months to observe it again. In 6 months, the Earth will have revolved halfway around the Sun. This shift of 2 AU, twice the distance between the Earth and the Sun, is equivalent to the distance between your two eyes. Just as your thumb will appear to shift position relative to background objects when viewed from one eye and then the other,